In this tutorial, we will learn the basic of paraView and how it is commonly used together with OpenFoam for post-processing simulation results. paraView is a powerful visualization tool that allows us to explore CFD simulation data, understand flow behavior, and generate high-quality plots and animations. In this session, we will go through several important features in paraView, including changing the legend and data range, creating streamlines, visualizing vectors, inspecting node data, generating plots over a line, and finally exporting animations. These tools are commonly used when analyzing OpenFoam simulations. Okay, let's start by first open the paraView. To load OpenFoam data, simply drag the file. Let's say this is my first simulation and trial1.foam file into paraView window. This case is a backward-facing step simulation, which is a classic CFD benchmark used to study flow separation, which we already discussed in our first tutorial. Once the file is loaded, click Apply in the Properties panel. At this stage, paraView will display the outer pressure field of the domain. However, what we really want to see is the flow behavior inside the channel. To do this, we can use the clip filter. Click Clip, then adjust the origin and normal coordinates so that the geometry is cut in the direction we want. After applying the clip, we can now see the internal flow region more clearly. By default, the displayed parameter might be pressure, but we can change this easily. Go to the coloring menu and select another parameter, such as velocity. You can switch between different variables depending on what physical quantity you want to analyze. Sometimes it's useful to inspect the mesh structure used in the simulation. To display the mesh, change the representation mode from surface to surface with edges. Now the grid lines will appear, allowing us to see the computational mesh used in the simulation. Next, let's adjust the color legend. Click the Edit Color Map button, then click the Choose Preset icon. From here, you can select different color schemes depending on your preference. We can also adjust the data range used for the color mapping. Inside the color map editor, you can enter a custom range manually or click Rescale to visible data range. Using the visible data range helps emphasize the variance in the currently displayed region. Now let's create streamlines to visualize the flow path. First, make sure the dataset trial1.foam is selected, not the clip or slice object. This ensures the streamlines are generated using the full domain. Then click Stream Tracer. Next, define the line source where the streamlines will be seeded. After clicking Apply, paraView will generate streamlines that follow the velocity field. If needed, increase the resolution to produce more streamlines, or reduce it to make it more obvious. To make visualization clearer, you can change the color from a variable field to a solid color. Okay, next we will visualize the velocity field using vectors. Let's click Glyph, then change the setting as follows. Then click Apply. You can adjust the scale factor to control the arrow size. You can also modify the color and arrow type to improve visibility. Vector plots are useful for understanding the direction and magnitude of velocity at different points. Sometimes we want to inspect the exact numerical value at a specific location. To do this, enable the Hover Cells tools. Now, when you move the cursor over the domain, paraView will display the data values for that cell. This allows you to quickly inspect parameters like velocity, pressure, or turbulent quantities. If you want to obtain data at an exact coordinate, you can use propagation. Simply define coordinates of the point, and paraView will return the value of all variables at that location. This is useful when comparing simulation results with experimental measurements, let's say. Next, let's generate a plot over a line. I first click Plot over line. Then define the start and end coordinates of the line. After clicking Apply, the paraView will generate a curve showing how variables change along that line. You can choose which variables to display in the plot. Additionally, you can switch the table view to see the numerical data. If needed, the data can also be exported as a CSV file for further analysis in tools such as Excel or MATLAB. Finally, paraView also allows us to export simulation animations. If your case has multiple time steps, you can animate the flow evolution. Simply go to File, Save Animation, then choose the format, resolution, and frame rate. Allows you to generate high quality visualization videos for your presentation or reports.